air and permits the intact hoses to continue normal operation. A stainless steel restraining cable is fitted inside each of the 2-inch air hoses to prevent loose end movements in case of a hose rupture. Standpipe valve assemblies are mounted atop each standpipe. The valve assemblies contain manual air hose shutoffs and a safety shutoff valve. The manual air valves are used for shutdown of a particular hose. Other valves identical to these valves are located on the compensator for isolating a defective hose from the DSC cylinders. In case of a hose breakage, the safety shutoff valve located on the standpipe valve assembly and on the DSC will slam shut and cut off the air supply to the defective hose. After this occurs, the manual valves at each end of the hose can be closed and the defective hose can be replaced. At the bottom end of the standpipes is a valve manifold assembly. The valve manifold's main function is to shut off and blow down the compensator. The manifold provides for shutdown of either or both standpipes. It is constructed of stainless steel and is equipped with pressure gauges for reading APV and individual standpipe pressures. When the DSC cylinders are vented and retracted during tripping, the venting is performed at the standpipe valve manifold. The APVs are isolated from the DSC at the standpipe valve manifold. The DSC is vented by opening valves SV5 and 6. When the DSC is returned to a drilling position, the standpipes and compensator are repressurized by first closing valves SV5 and 6. The compensator is now ready to be returned to operation. Serving as the operating gas volume for the DSC, the APVs are rated at 2400 psi. There are two types, the power APVs and the standby APVs. As a cylinder rod stroke, the gas expands or compresses to and from the power APVs. Since the APV volume is large compared to the volume displaced by the rods, system pressure variations due to expansion compression of air as the cylinder rod stroke have minimal effect on the compensator supported load. The standby APVs are used to charge the air pressure setting in the power APVs. The standby bottles are maintained at 2300 psi. When a rapid increase of DSC force is required, air is throttled from the standby system to the power APVs. This is a convenience in that the compressors could be used to increase the pressure, but the time required in pumping would delay the drilling operation. Let's briefly review the DSC system. The DSC is a motion compensating system designed to nullify the effects of drilling vessel heave on the drill string or other hook-supported equipment. It is mounted in the derrick between the hook and the traveling block. Its major functional elements include the mainframe, which contains the cylinders, rods, sheaves, chains, air oil reservoirs, lock bar subassembly, and the traveling block interface. The hook frame assembly, which supports the hook on its bail. The air power supply, which consists of power and standby APVs, compressors, the hose loop, standpipes, the standpipe valve assembly, the valve manifold assembly, and the piping. And the driller's control console, which contains the hook position indicator, valve controls, the weight indicator, and gauges. Now let's cover some typical DSC operational procedures. The first operational procedure we'll cover is drilling the pilot hole. During spudding in or drilling the pilot hole with a free string, the ability of the string to be targeted to a point on the ocean floor is a trial and error operation. Repeated collisions with the ocean floor are possible. The string in this state is very fragile, and if the entire weight of the collars is set on the bit, collapse of the string is possible. When using the DSC, the weight on the bit or casing shoe can be made very slight so that the string can be picked off bottom repeatedly and re-stabbed into position to the target area. Weight on bit or shoe is then increased slowly by bleeding off air pressure. The second operational procedure is landing and retrieving the BOP stack. This function has been done for years using riser tensioners. However, with the DSC offering finer control over weight, the stack can be landed on the wellhead with very little collision force. This ensures that damage to the casing and stack seal interface will be minimized. The DSC can be set to such a low contact force that something as large as a stack can be made to hover over the wellhead and nullify all relative motion. In most cases, the landing operation has been smooth with 5,000 to 10,000 pounds weight on the stack connector. The DSC is stroked out fully and lowered. When contact is made, the DSC strokes up, maintaining the desired force on the wellhead connector. If for some reason the stack is not setting squarely on the wellhead, it can be picked up and re-stabbed again. Once stabbed, the riser can be attached to the riser tensioners at the cellar deck. The third operational procedure is running casing. For the first string of casing, such as the 30-inch size, the targeting of the casing into the open hole is performed as we outlined in operational procedure number 1 in drilling the pilot hole. However, for other casing strings where the casing is guided, the DSC can be used to limit the landing force. In the case where bridging or sticking occurs, the casing can be damaged. By compensating, this will enable safe procedures for circulating and freeing the pipe. The fourth operational procedure is making up and backing off running tools. This is a frequent function which usually requires low tension on the string to accomplish the operation. The DSC can be readily adjusted to form a neutral tension point in the string to facilitate the release of the tool. If some prescribed positive upward or downward force is required, the DSC can accomplish this function. The fifth operational procedure is logging. In this operation, a dead line is hooked from the riser up through the rotary table to an auxiliary hook sheave on the DSC and then dead-ended on the drill floor. This maintains a reference position of the hook relative to the earth. The logging live line is inserted in the riser and is fed through the rotary table to a second auxiliary hook sheave on the DSC and back down to a snatch block mounted on the drill floor in the same place as the dead line is fixed. The logging line can then be fed from this snatch block to any part of the vessel for the logging operation. The key factor in rigging this unit is to have the same number of parts, line, and location of anchors on both the logging line and the dead line. In this way, absolute position control can be assured with no direct reference to the bottom of the hole. The sixth operational procedure is packer setting and retrieving. By using the DSC, absolute position and weight control can be accomplished when setting or retrieving packers. The seventh operational procedure is coring and drilling with diamond bits. The key to successful coring and diamond bit usage is to land the tool softly on bottom and to control the bit accurately. The use of the DSC permits the driller to control the desired value of bit weight from the drill floor at all times. The eighth operational procedure deals with fishing operations. The various fishing tools generally use some self-activating device to grab the string. The tools must land on the downhole target without damaging either the fishing tool or the tool to be retrieved. In this case, the DSC can land on target with the desired impact load and make repeated stabs, latching and retrieving the target. The ninth operational procedure is using the DSC to tension the riser pipe. This function is a backup function where the stack and riser are run latched prior to the mud hoses and tensioner lines being attached. The DSC can then be used to control the riser while the mud hoses and tensioner wire lines are made up. The 10th operational procedure is concerned with hanging onto the string during a well kick or other emergency situations. The DSC maintains a motionless string as the vessel heaves. This enables easier position of the string in the BOP stack prior to closing the rams. With bumper subs, the weight on bit cannot be altered. When a power failure occurs, a string can lie stuck downhole and the hole can be bridged. With a DSC, the bit weight can be decreased to a minimum value by using the system's standby APVs. This ensures that the bit will not sink into a soft formation and become lodged. Since the string is motionless, junk is not being torn off the walls by the pipe motion. The 11th operational procedure is pulling on stuck pipe. Pipe sticking while drilling is an ever-present danger. A procedure that has been used with good results is performed like this. Half of the APVs are closed off. The DSC is pressured up with the standby APVs to 320,000 pounds. The DSC is stroked out, increasing the load to 80 to 90% of the yield point. A mud additive is circulated while occasionally jarring with the DSC to 80 to 90% of the yield point by raising the traveling block. As the pipe begins to come out when the sticking force is lowered, the DSC is locked and the pipe is pulled out of the hole. The 12th operational procedure is drilling operations. This, of course, is what you will see the DSC do more than any other operation. The primary purpose of the DSC when drilling is to eliminate the effects of the rig's heave. This keeps the bit on bottom and maintains bit weight. Since the driller has control over bit weight, he can vary the bit weight at any time to improve penetration rate. The DSC also acts as an automatic driller as long as the stroke capacity is not exceeded. For example, with an 18-foot stroke DSC and 5 feet of rig heave, 10 feet of hole can be made before the traveling block has to move. Improved bit wear is also achieved as a result of the dampening characteristic of the DSC on drill string vibrations. Here's a listing of the typical DSC operational procedures we have just shown you. 1. Drilling the pilot hole. 2. Landing and retrieving the BOP stack. 3. Running casing. 4. Making up and backing off running tools. 5. Logging. 6. Packer setting and retrieving. 7. Coring and drilling with diamond bits. 8. Fishing operations. 9. Tensioning the riser. 10. Hanging on to the string during a well kick or other emergency situations. 11. Pulling on stuck pipe. And 12. Drilling operations. Now let's take a look at how to put the DSC into operation. This procedure should be performed before first startup or when the DSC has been idle for long periods. First, inspect all piping and hoses to ensure proper hookup. Second, check the fluid level in the air-oil reservoirs. With the rods retracted, the fluid level should not be below the lower sight glass. The needle valve on top of the air-oil reservoir must be opened prior to operation. Third, check the fluid level in the DSC cylinder blind end cushions. Fourth, check all sheaves to ensure that they are lubricated and free running. Fifth, check the chains for lubrication and end fitting condition. Sixth, connect the 4 high-pressure hoses to the DSC and open the isolation valves at each hose line. Seventh, connect the air oil reservoir charge hose. Eighth, pressurize the air oil reservoirs to 15 psig with the rods retracted. The regulator is located inside the control console. Ninth, move console valve V2 to the 2-system position. Close valves V3 and V5. Tenth, move valve V4 to the decreased position. At the standpipe valve manifold, open valves SV8 and SV9 and close valves SV1, 2, 3, 4, 5, 6, and 7. At the console, press the start button to start the compressor. 11th, charge the standby APVs by moving valve V4 to the increased position. Portions of the system can now be charged, such as the DSC cylinders, the power APVs, or any combination. 12th, after the system is up to pressure, the main valves SV1, 2, 3, and 4, located at the standpipe manifold, can be opened. The 13th step, checkout of the lock bar system, should not be performed until the system is pressurized to a level where the cylinder rods are extended, causing the chains to be under enough tension to lift the hook frame. Lifting of the hook frame must be visually verified. Inadvertent operation of the lock bar, if not in the full lock position while the system is depressurized, will cause the hook frame to fall until stopped by the chain. Lock bar system checkout is performed as outlined in the DSC System Operations and Maintenance Manual. After lock bar checkout, it can be unlocked and DSC stroking can be initiated.